Well, I'm at it again. I saw another great problem. I love problem solvers. One of the things that I always look for when I'm solving a problem is to see if it's solvable. Sometimes they'll give you not enough information. In this particular case, that's what I thought was going on. I saw this problem right here, and I love this problem. You have your three angles, and they're all 60 degrees. You got a semicircle with a 10-unit radius. And you've got to find the length up here of AB. Now, when I looked at this problem, I got to thinking, there's no way there's enough information. So I went right into it to see if I could find out if it was solvable. And indeed, it is solvable. To make a visual of this, I created a dynamic Desmos model just to show that segment AB is actually equal to the radius of the circle. And keep in mind that at point C, they're divided into three 60-degree angles. When I first saw this problem, as I stated earlier, I wasn't certain if there was enough information. Now you can look at the Desmos mathematics and see the proof that I used. I'm not going to do a formal proof. Although I think this will suffice. I've included all the things I needed for labeling. You're welcome to use this. I'm going to put a link for this if you want to experiment with it yourself. But I added the opportunity to change the radius, change the distance from the origin, and you can manipulate both of these. So first of all, finally, the distance is what I'm going to do, and you can take the point and actually physically move it. Now, as you watch AB, it moves around. The angles from point C all remain 360-degree angles. That's angle ACD, ACB, and BCE. Those angles are always 60 degrees. They're locked in. You can see it how I did it here in Desmos to keep those angles where they need to be and to make sure they're 60. Initially, I wasn't certain that you could even answer this one, but after a close examination, I discovered that AB will always be the radius. And so with that being said, let's take a look at, as we move the distance around, also down here at the bottom, I have the length, which here the length is 10. And as you can see up above, I created the radius of 10. So if I want to make this smaller, you can actually do this. You can change your radius. So like, let's suppose I decide to make the radius 7. You can still manipulate this, and AB will continually be 7. As I move down below, you can see the length is 7. So please feel free to use this, experiment with this. As a problem solver and a math teacher, a picture paints 1,000 words. And whenever I create one of these models, I let the students use it. That way they can manipulate it and see for themselves and appreciate the mathematics behind it.
MathMan approves. Please remember to like and subscribe.